So here we'll do C, D, and E together. So C, prove that g of f of x does not exist. So what I want to do is just look at what's happening here. So we want to do g of f of x. So the first function that we're performing here is f of x. And then we're performing the function g on that. So it's g of f of x. So that's going to be the starting off with the domain of f. It's going to map into the range of f. That's the first part of the composite function. The second part is g. So you're starting with the domain of g. We're ending up with the range of gof, whatever that is going to be. This is going to be the key part to deciding whether it exists or not. In this case, we know it doesn't exist. So domain of f was r. So here, say that that's going to be r. The range of f was negative infinity to 9. So this is negative infinity to 9. So what's going to happen if it doesn't exist is we're going to have values here that don't lie within the domain of g and hence stop it working, stop it existing. Your domain of g is negative 2 to infinity. So you'll see why this is not going to exist. There's going to be lots of values here, you know, anything less than minus 2 is going to stop that you're getting out in the first part, is going to stop the second part working. So that's why it doesn't exist. So what we say for that is we say that, well, the range of f is not a subset of the domain of g, therefore it doesn't exist. Okay, so it does not exist. All right, and as long as you've got your domain and range table, and then everything here, then you've proved that. So part D is the largest domain of the function, so that it does exist. I don't know why it says f, but the largest of g of f of x, so it does exist. So for it to exist, then we can only have values between minus 2 and infinity. Okay, so what we want to do is we want to change the values that we're getting out here that are stopping the second part working. And the only way to change these values is to change what you put in. So we need to change the domain of f. Okay, so that's what the question said, actually. Makes sense. All right, so what we want to do now is just understand that this is only going to work. Okay, so for part D here, this is only going to work when the range of f is minus 2 to infinity. So the range of f has got to be greater than or equal to minus 2. Now when you're working out what the values that you're getting out for the range of f, you're using the function of f. So we know the function of f is 9 minus x squared. So we can say that 9 minus x squared, whatever we're putting in there, must give you answers greater than or equal to minus 2. Now I want to solve this. So what I'm going to do is I'm going to take everything over to the right. Okay, whichever way you do it. It doesn't matter, you could bring everything to the left. I'll just do it this way. So x squared here, take away 9, so that's minus 11. So basically here you're looking for where x squared minus 11 is less than or equal to 0. So we're solving a quadratic equation. So I've got it like this. So it's going to be x squared minus 11. So if I solve that to find out the intercepts, x squared would equal 11, x would equal plus or minus root 11. And then what I'm looking for here is whether it's less than or equal to 0, and therefore it would be this section here. So that means that my domain must change between negative root 11 and root 11, and it would include the values because we're including them for 0. So if you did it the other way, I mean, you could do it like this. So you could have taken this over here, it would be 11 minus x squared is greater than or equal to 0, you see, which would be like this. This would still be minus root 11 and root 11. So where it's greater than 0 would be this section here, which would be the same. So it doesn't matter which way, I just always rearrange it so you get x squared as a positive. So for E, we want to look at what the range is going to be. So we know that from before, this is going to change now. So the domain of f is going to be minus root 11 to root 11, including those values. So if we just look at the graph for f, for the first part of the composite function, and it's going from minus root 11, should be about here, to root 11, which is here. So when you sub in minus root 11, it's going to be 9 minus root 11 squared. So it'll be 9 minus 11. So this will be minus 2. Okay, so this point here will be minus root 11 minus 2. And then substituting in root 11 here. So root 11 squared is 11. 9 minus 11 is minus 2. So you'll see now that the range that's going to be produced now will be between minus 2 and 9. So that is going to be your new range here. So this range, you see, is going to now not be this anymore. Okay, I'll maybe write it down here. So if we've got x, and we're going to f of x, and then we're going to g of f of x. So it's all changed now. So we get f and g. So we know that the starting off with the domain of f. Now the domain of f we know is going to be minus root 11 to root 11. Okay, and that's going to map into the range of f. So if we look at our sketch here, as we did before, you know, it's only going to go up to 9. That's the maximum part, so it's going to be from minus 2 to 9. That's going to be your range of the first part. That's the answers that you're going to get out here. So minus 2 to 9. Not infinity like we had before. So in the second part here, the domain of g. So now the domain of g was minus 2 to infinity, but now what it's going to become is it's going to become minus 2 to 9. Okay, so what we need to do is look at the graph of g and see what the range is going to be between minus 2 and 9. So if we come up to see g, so there's minus 2. And what I want to do is find out what 9 is going to be here. So what this coordinate is going to be, it's going to be 9 something. And you see if I substitute it in here, it's going to be 9 plus 2, 11, square root of 11. So this is the only part that's going to exist in the composite now. So therefore the range of the composite function is going to be 0, but it's going to stop at root 11. So the range here is going to be 0, and it's going to go up to root 11.